Welcome again, everybody, to my peer teaching on absorption. And in this video, I will be going over some necessary concepts in absorption and their equations. So, first, I want to talk about I'm going to butcher this, Freundlich equation. The Freundlich equation is used to describe the relationship between the amount of absorbent and absorbent sorry the amount of absorbent absorbed onto the surface of the absorbent, and just as a reminder, the absorbent is the substance that's being absorbed, and the absorbent is the surface of that is the absorbent is like latching itself onto, basically. And the concentration of the absorbent in the surrounding liquid or gas phase. So you can see the equation there. The Y is the weight or volume of gas absorbed per unit area or unit mass of absorbent. And our K and N there are constants, are empirical constants, which are dependent on the nature of the solid and absorbent on the temperature. And then your P is your equilibrium partial pressure. And then the equation, that second equation there, is I got these from the textbook, and I'm only guessing that the second one is if you don't want to like deal with the exponent. And then the picture on the right here is the types of absorption isotherms, which I will go into a little bit more detail on the next slide. So next and lastly, I would like to talk about the Langmuir isotherms. So like I mentioned on the previous slide here, we have these absorption isotherms. So what is an isotherm? It's basically just some sort of representation. Typically it's graphical or mathematical, and it basically describes the relationship between the concentration or amount of a substance absorbed onto a surface, so the absorbent, and a specific variable, such as pressure or concentration, and either of those at a constant temperature. The isotherm itself means same temperature, basically alluding that the measurement is made under made under a constant temperature conditions. And then the Langmuir isotherms describes the absorption of molecules onto a surface, with the assumption that adsorption occurs in a monolayer and that there are no interactions between absorbed molecules. So yeah, these are a bunch of different equations here, and we have some new variables here. Y is still the same. That top right equation there, it's probably going to be your bread and butter if you're trying to you know, I guess solve a problem on this. Our P is the same, and you can also, with this bottom right equation, find the equilibrium partial pressure per weight or volume of gas absorbed. That's also per unit area or unit mass of absorbent. And we have a new variable here, theta, in this bottom left equation. It's basically just the fraction of the total surface covered by absorption molecules at any constant. And then K1 and K2 are going to be your constants, but K1 um, is proportionally constant, and then K2 is the rate at which molecules evaporate from a unit surface when the surface is fully covered. And yeah, so that is absorption in a nutshell, and that's all I have for this video. Looking forward to seeing everyone in the learning conversation and talking about absorption. See y'all later.